Let's dive right into this explainer and take a strategic look at exactly how modern web applications connect to data sources through API integration. Now, if you've been working in or around the modern web, you already know that seamlessly bridging the gap between client interfaces and those complex backend databases is basically the core of what we do. It's the whole shebang. So today, we're going to unpack the architecture of that connectivity. We're looking way past the absolute basics to really understand the mechanics of how data is efficiently requested, managed, and secured in professional-grade apps. I mean, just think about the fundamental shift that's happened in web dev over the last decade. We completely moved away from those static, server-rendered pages where every single little interaction required a painfully slow, full-page reload. Today's standard, it dictates that applications are state-driven client interfaces. They're breathing, constantly updating with new messages, live weather, and streaming data, all through asynchronous data fetching. And that massive transformation from static documents to dynamic software relies almost entirely on sophisticated API integrations. So here's our roadmap for tracing the journey of a single data request. First, we'll cover the basics of APIs. Second, mastering CRUD operations. Third, perfecting the user experience. And finally, scaling and security.
All right, let's establish our foundational landscape right now with Section 1, the basics of APIs.
Before we can even think about manipulating data, we need to acknowledge the architectural constraints we're operating in. REST APIs absolutely remain the gold standard for requesting and receiving data over the web. And while you might be super familiar with it as a strict set of rules, the true power of REST actually lies in its statelessness and its reliance on standardized HTTP methods. When a client app queries a distributed cloud server, REST provides this incredibly predictable grammar. It ensures the system doesn't have to remember any previous interactions just to understand the current one. That statelessness, that is exactly what allows modern infrastructure to scale so horizontally and so reliably. Now, when it comes down to actually executing those requests inside a JavaScript environment, we generally lean on two primary vehicles, the native Fetch API or Axios. Fetch is the native browser standard, right? It's lightweight, requires zero dependencies, and it leverages native promises beautifully. But there's a really good reason professional teams frequently opt for the third-party overhead of Axios. Axios just hands you these built-in quality-of-life features that Fetch natively lacks. We're talking automatic JSON stringification and parsing, super reliable request cancellation, and those incredibly useful request and response interceptors. Honestly, both get the asynchronous job done, but Axios abstracts away all that boilerplate you'd otherwise be stuck writing yourself. Moving right along to Section 2, Mastering CRUD Operations. Once your connection is established, the actual data manipulation relies on a standardized framework. Basically, every single data interaction you can possibly think of boils down to just 4 operations: create, read, update, and delete. And in a RESTful architecture, these align perfectly with standard HTTP methods. Create maps right over to POST requests for sending new payloads. Read is your standard GET request, just pulling states without changing them. Update uses put or patch for modifying records. And delete, well, it appropriately uses the delete method. Look, whether you're building a tiny internal tool or some high-frequency financial trading dashboard, mastering how these CRUD operations align with their correct HTTP verbs is absolutely non-negotiable if you want clean data manipulation. But hey, taking action takes time. Which brings us to Section 3. Perfecting the user experience. This is where we have to account for the latency that's just inherent in network requests. The lifecycle of a professional API call is super precise. Step 1, a user initiates a request. Step 2, the client immediately acknowledges that intent by showing a loading state. And Step 3, the client resolves the response by either rendering the new state or gracefully catching any errors. If your app logic drops the ball on that middle step, the acknowledgement part, the illusion of a high-performance application shatters instantly. Just imagine clicking a critical submit button on a form, and literally nothing happens. You're just sitting there. You wait. The network is resolving in the background, but visually, the app looks completely dead. So you click it again, and oops, you've just fired off a duplicate post request. This right here is why loading states, and more specifically, optimistic UI updates, are totally the unsung heroes of user retention. When an API takes a couple of seconds to resolve a heavy query, a smooth skeleton screen or a progress indicator bridges that latency gap. It reassures the user, hey, we're working on it, keeping them engaged instead of totally frustrated. And what happens when that network request inevitably fails? Because it will. A dropped connection, an expired token, maybe a server timeout. Proper error handling is your vital safety net here. Truly exceptional applications don't just throw generic errors or fail silently. They provide actionable feedback and really safe fallbacks.
Instead of showing a broken interface, the app contextualizes the failure. Maybe it renders a cached version of the data, or just gently prompts the user to check their connection and retry. It essentially transforms a scary technical failure into a manageable, temporary little hiccup.
Finally, we've made it to Section 4, Scaling and Security. We really need to talk about how we manage data when our app hits enterprise-level scale. Managing data efficiently at that level requires strategies like pagination. It's exactly how we prevent client-side bottlenecks when dealing with incredibly massive backend data sets. Think about it. Instead of completely overwhelming the browser's memory by trying to fetch and render 10 million records in one giant GET request, we fetch small parameterized chunks. Whether you go with offset-based or cursor-based pagination, controlling that payload size ensures your app stays lightning fast and responsive, no matter how ridiculously huge the underlying database gets. And the very final piece of this architectural puzzle? Authentication APIs, the security checkpoint. We've mapped out how to effectively fetch and mutate our data, but locking down those endpoints is absolutely paramount. Authentication is the definitive gatekeeper. In modern setups, we're rarely just passing a simple username and password on every single request anymore. We're dealing with robust mechanisms like JSON Web Tokens, JWTs, and complex OAuth flows. These securely pass cryptographic proof of authorization right in the request headers. They guarantee that your CRUD operations are strictly scoped to the exact permissions of whoever happens to be authenticated.
So we've traced the entire lifecycle together, from leveraging the stateless rules of REST and the awesome utility of Axios to mapping our HTTP verbs to CRUD operations. We've talked about managing latency through loading states, catching errors smoothly, optimizing payloads with pagination, and finally securing our endpoints with JWTs. It's a highly engineered ecosystem, all executing in literal milliseconds. Which leaves us with this final thought to ponder. As you're architecting these seamless integrations and navigating complex user permissions, who truly holds the keys to the data you interact with every single day? Keep questioning, keep optimizing, and thank you so much for joining me on this explainer.